Welcome all attendants to the webinar on nano training organized by PEROSH, the Partnership on European Research in Occupational Safety and Health. Before I introduce the program to you, I would like to highlight our anniversary, because this month in November, PEROSH celebrates its 20 years of existence. And if you are interested, I would really like to invite you to come to visit our website and to have a look at all the materials that we have there and that you can download for free. We had a fantastic research conference in Stockholm early September, and also there a lot of researchers shared their experiences. We had some fantastic keynote speakers from the Commission, experts in Europe, and also all these videos of keynote speakers and of the PEROSH researcher colleagues, you can see on the website and in our YouTube feed. And if you want to stay connected with PEROSH, please subscribe on our website to our newsletter and our events and webinars. And if you do, you will always receive an invitation for these activities of PEROSH. Now, we go back to the webinar. We will start in a minute. A few house rules, for most of you probably quite familiar. This webinar will be on video. So after the webinar, a video will be published on the PEROSH YouTube feed, so you can always have a look there. Some of the speakers will share some interesting information with you, and you may want to have a look again at the video to grasp the full volume of this information. It's a lot of information they will share with you. This webinar is based on the results of a joint research project within PEROSH. We have a couple of these joint research projects where at least 3 of our members join forces to do some research on a specific topic. And in this case, it was on nano training and design. We have 4 speakers. This time the webinar will last for 1.5 hours. So this is a bit longer than we normally have, 1.5 hours. And if you have questions, you can post these in the chat. I'll have a look at these questions, and I will forward the questions to one of the speakers to get an answer from them. If you also leave your email address in the chat, you will always receive an answer, even after the webinar, if we have too many questions to process. So please leave your email if you really want to have a response from one of the speakers, and we will organize this. Okay, then let's start, and I will start with the project coordinator. His name is Fabio Boccuni from INAIL. This is the Italian member of PEROSH, and his talk will be on the PEROSH project on training on emerging risk in R&D and production of advanced materials and nanomaterials. Now Fabio, he is graduated in engineering at University Sapienza in Rome. At present he is a senior researcher at INAIL in the Department of Medicine, Epidemiology, Occupational and Environmental Hygiene. And he carries out several research on emerging risks for health and safety in the workplace, and with particular reference to the assessment and management of risks associated with new technologies, innovative materials and nanomaterials. That is his speciality. Since 2021, Fabio is part of the Italian delegation of the OECD Working Party on Manufactured Nanomaterials. A few of the other speakers are also a member of this group, as far as I have understood. And he is the project leader on training risks in research and development and production of new and advanced materials and nanomaterials. He was also speaker at more than 50 conferences and seminars, and he is the author of over 100, that is really a lot, over 100 publications, including peer-reviewed articles in scientific journals, book chapters, monographs, and abstracts for conference proceedings. Fabio was also attending our last conference of PEROSH in Stockholm, where he had a fantastic abstract, presented a fantastic abstract. Fabio, let us hear your speech.
Yes, thank you very much, Michael. Very nice presentation. So, thank you. I would like also to thank the PEROSH to arrange this webinar. I will try to share my screen. Just a moment. I will include the presentation. Okay, please inform us if you are able to see the screen. Okay, thank you also to the other speaker to agree to participate in this webinar. As Jan Michael mentioned, my presentation will be focused on to describe the project activities that we made in this network. The focus is on training on emerging risk with specific reference to the production, research, development, and use of nanomaterials and advanced materials. So emerging risk related to introduction of new processes and new materials. So just a brief outlook about my slides. I will introduce a little background of this specific sector. Then I will focus on the project activities, a brief summary on the major outcome that we achieved, and then the project dissemination plan. In the last slide, I will introduce just some questions and next challenge we'll be able to answer in the future. So just to remind to all the audience that the training activities are mentioned in the EU Directive 391 on safety and health at work as activity to prevent risk in charge of the employer that shall ensure that each worker receive adequate health and safety training with particular reference to the introduction of new technologies. And this training should be adapted to take into account new ever-changing risks. So this is the case of the introduction of nanomaterials and new advanced materials in the processes. So training activities are also in line to the European strategic vision and framework on health and safety at work, because training activities are useful to prevent risk, but also to protect workers in the view to promote the safety and health of emerging risk, in particular in the view of safety and sustainability of new and emerging risk in new workplace scenarios. So just to have some common points and definitions about nanomaterials and advanced materials. As you probably know, the European Commission made a very kind work in the definition of nanomaterials by the publication of a recommendation in 22. That is the work of about 10 years, because the first recommendation was in 2011. So nanomaterial is defined as a natural or incidental or manufactured materials consisting of solid particles or aggregates or agglomerates, where about up to 50% of or more of this particle have a size distribution in the range from 1 to 100 nanometers. So this is a very complex definition, but it is very comprehensive. And then JRC made a guidance to correctly apply this definition of nanomaterials. So in the other hand, we had a lot of work in the OECD Working Party on Manufacturing Nanomaterials to propose a working definition of advanced materials. The acronym is ADMA. The point in this case is highlighted in the new or enhanced properties of the materials and the specific property that we have the objective to achieve specific or improve the functional performance. So ADMAR are a group of materials that are also described in this guidance from the OECD that also include in some parts also nanomaterials. And the point is the new and enhanced properties of materials. So in this background, our role at Occupational Safety and Health Institute is to promote safe and sustainable development of these new and advanced materials, with particular reference to nanomaterials. And in this background, we started our research project by involving 5 PEROSH Institute, INAIL from Italy, but also INSST from Spain, the NFA from Denmark, TNO from the Netherlands, and STAMI from Norway. I think some colleagues are also in the audience of this webinar today. But another value of this project was also to involve some external partners that made a strong contribution in this project. Such partners include some universities and research institutes active in the field of nanotechnology and new advanced materials, such as Scuola Normale from Italy, Tyndall Institute from Ireland, and IMEC from Belgium. But on the other hand, we have also the opportunity to involve in the project some industrial associations in Italy, AIRI, and Andrea Porcari will be a speaker also in this meeting today, and then the Nanotechnology Industry Association at European level. So a very kind partnership. The first aims of our research was to review and compare different approaches for occupational safety and health with reference to nanomaterials and advanced materials, and to propose a guidance document on harmonized training modules and to design the next training in this field. So we started with a comparative study, then we was able to make a stakeholder consultation, and then next year, at the beginning of next year, we will be able to propose this guidance document to PEROSH. So today we started the dissemination of results, and then just to outlook about the starting milestone, because in our work of review of previous initiative, we highlighted that we had very limited initiatives on training for nanomaterials and advanced materials. In particular, there were no studies that established the workers and other OSH players' needs. So, for example, WHO guidelines in 2017 recommended to consider the training of workers and the involvement of workers in health and safety issues as a best practice, but they do not highlight or promote one form versus another of training and involvement. So another problem is also to evaluate the effectiveness of the training and also to transfer the training into practical activities. So in this background, we was able to produce some deliverables and outcomes of our research studies. The first one was a comparative study on existing initiative among the project partner countries, and then the stakeholder consultation and final guidance document that I mentioned before. So just to highlight some results of the comparative study, we collected 33 training initiatives from 2006 to 2022 made by the institute who participate in our project. General picture is that the majority was guidance document to be available for free by our different websites, but in the other hand we have also webinars for 24% and also training courses modules. The main target groups was OSH professionals, and the second place employers, and among the rest students, researchers and OSH authorities. So only 36 initiatives include practical experience, and the great majority was for free. Just a last reminder about the project result dissemination plan. Today we start with this webinar. We hope that this initiative will be also replicated in other contexts. We have in mind to participate to the next international conferences next year, for example, in ICO 24 and the next IO conference, and also to the Nano Innovation Conference in Rome in 2004. We are able to consult our documents in the PEROSH website, and that we have also in mind to start a second round of web survey addressed to stakeholders, and also you can see the link to participate to this survey in my last slide. So to conclude, some questions and major points that arose from our research. I think that these points could be also useful to start a discussion among this audience today. We highlight the question related to the transfer into practical initiatives, the guidance principle. The question also related to the role and the responsibility of employers to take and carry out risk assessment in the workplace, but also in the other hand, the information and training for OSH professionals on new methods for risk assessment in this field. And in any case, there are some points and questions related to the extension of training approach for nanomaterials also to new and advanced nanomaterials. So we will try to answer of some of these questions in the next presentations, but a lot of work is going on in the next years in order to have a comprehensive and harmonized approach on this sector. So just to thanks another again the other participants. You can use this QR code in order to connect to our survey. I think that the link will be also posted in the chat of this meeting. So I would like to thank you for your attention. I will leave the floor to Jan-Michael for the next part of the webinar. Thank you very much.
Thank you very much, Fabio. Really interesting, concise presentation of this project. Thanks a lot. And indeed, we have now 85 participants online watching our webinar. So if you guys feel motivated to join in with the next survey, please scan the QR code. You can also see this QR code later in the video, of course, that will be published, and send it forward to other people who might be interested in joining in this second survey. Now, Fabio, I have a question to you. I didn't see any questions yet in our chat. Please, those who are viewing, feel free to post a question and we will try to answer it. What I noticed, and you also made this remark, is there seem to be hardly any trainings for workers when it comes to nanomaterials? They're experts for sure, or practitioners.
Yes.
So I can imagine
Yes.
that health and safety manager, for instance, needs to know, okay, what is the exposure? Yes. How can we? That is a typical, I would say, specialist training. But what is your opinion on this fact that
yes.
there seem to be no training for workers at all who are confronted with nanomaterials, advanced materials in their production processes?
Thanks. Thank you, Jan-Michael, for this question. The first point is that in any case, the comparative analysis was made among our research institute. So, as you know, our research institute in our field have in charge the appointment to train experts in many cases, or in other cases authorities represented. So we have a role to give guidances, and also in many cases with the OSH experts or other researchers in this field. So less with the workers, in particular for our institute. So we should give guidances to the trainers,
okay,
for the workers, but in the majority of cases it is the point. But some little initiative was addressed to worker safety representatives that are in any case workers, because they are representative workers, but workers from some in some cases. So in this way, I think that the next presentation will be also useful also to answer this question, because interesting point of view was highlighted in particular from the survey results.
Okay, thank you very much. So that explains why we have a lot of comparative material on training specifically for specialists. Yeah, indeed. Okay, I will introduce the next speaker to you. His name is Andrea Porcari, and he will say a few words on training practices, on nanomaterials, advanced materials, for workers' safety and health. So here the target group of the workers indeed comes a bit closer. Their common training needs, the challenges and advices from stakeholders. Now, Andrea Porcari works at AIRI. He has a degree, a laureate degree in physics, and several years of experience in working in the semiconductor industry. He's a project manager at AIRI, which stands for the Italian Association of Industrial Research, a not-for-profit organization working with researchers, with research industry, financial organizations, public bodies, and civil society organizations on strategies and policies for science and technology. He joined AIRI in 2005. He contributed to more than 20 European and national projects aiming to promote emerging and enabling technologies. His current interests are related to technology assessment, technology transfer, and risk analysis. And also, Andrea is a member of the OECD working group, the same as Fabio, on safe and innovation approach, and also of the UNI, I think that is United Nations group. Is it, Andrea? Maybe not.
No, it's the standard body. It's the national standard body.
Italian standardization body.
Yeah, okay. Exactly.
So the Italian standardization body, Technical Committee on Nanotechnologies. So Andrea is also a member of this group. Andrea, please.
So thanks, Jan, for your kind introduction, and thanks to all the participants. I'm very glad to be here today to present to you some of our activities that have been performed in cooperation with the Nano Training Project, and before also with the Go4Nano project. So that's part of activities were done in cooperation with Go4Nano. So one second, I'm just Okay, so a few words you already said, but our mission is to promote industrial research. We work since 15 years with this mission, and we are one of the known parish partners of this project with 85 members and a large network of research innovation players in Europe. And we are working in many aspects related to enabling technologies, including training, education, and dissemination. And we are working on safety and sustainability of advanced materials and nanomaterials since I think more than 15 years in different European and national initiatives. So it's really part of what we are doing on a regular basis. Just going into our survey and our results, Fabio already presented our mapping exercise that has been complemented with results from a consultation of stakeholders and analysis made by the Calibrate and Govern Nano projects. You can find the name of the deliverables, and you can navigate into the websites of the two projects and find the deliverables if you like. We made the survey at the end of 2002. We sent it to 150 experts. We got 58 reply from, I think, quite authoritative experts throughout Europe, 16 EU countries represented from plus some non-EU countries, more than half from public research, rest from authorities, policymakers, industry and consultancy, 14% belonging to OSHA authorities and parish members. Most of the people already experienced in a way or the other on training. Yes, there are limited training initiatives on OSH of nanomaterials, and most seem to be performed on an occasional basis. It seems like, at least from the public information we got, there's limited internal training companies and research and innovation organizations on this topic. And this seems somehow, at least for us, in contrast with the quite ample marketplace for training in chemical safety and product sustainability. I think you can find hundreds of courses on this. But, I mean, on the one hand, in many cases, nanomaterials are treated as chemicals, as usual chemicals. And I mean, the safety measures you take for chemicals may be applicable to nanomaterials, but as well, there are some peculiarities and specificities. And our guess is that often organizations just have a consultant person that is looking at the safety dossier and is also overseeing and advising regarding risk management and risk analysis of nanomaterials. But again, this should be confirmed by more in-depth analysis. At the final conference of a Govern Nano project I mentioned you before, there was this slide giving a very overall synthesis of the gaps for risk governance of nanomaterials, and some are for sure relevant also for the OSH field, in particular the issue of understanding risks and the fact that we have a complex information and data landscape. We start now with the results of our survey. Here is about the needs and gaps of OSH of advanced materials and what could be addressed by professional training. And most of our experts said that harmonization of criteria, procedures, and methods for risk evaluation is very important. And moreover, finding ways to address the complexity of materials. And going on, there's the scarce knowledge of risk assessment tools, data uncertainties and gaps, and so on and so forth. So there's a need of dice to navigate in these complex risks. If we look at what could be the ambitions of OSH professional training, first of all, and for the majority of people, the anticipation and prevention of risks, followed by practicing with tools and methods for risk analysis. And there's also some aspects related to the integration of nano-specific activities with usual traditional risk management measures, and also aspects related to increase of professional skills and competencies of workers. Overall, a better understanding, awareness, and acceptance of potential risk of exposure of nanomaterials during manufacturing is something that would be worth communicating during training. When we look at the target audience of the training, overall, health and safety managers, OSH professionals are the first one to target. So the people that are in charge of the training the trainers would be something that should be done. So train the people that then will train the workers. Of course, many of our respondents underlined that each of the targets may need different training contents and formats. So the training should be shaped to the needs of a specific target. We asked about the most important topics for the training, giving a number of options related to the specific aspects of nanomaterials. And as you can see in the slides, all have been selected as important, above all risk assessment and management in hazard information. So this shows that it's complex, and training need to take into account different aspects to fulfill the unknown on the gaps in knowledge that are currently present. So there are as well barriers to implement training. First one maybe is obvious, resources and costs. Second one I think is less obvious, is about limited interest and engagement of professionals and participants. So there's an issue here. Why there's a limited interest? Because there's no need, or maybe because there's a lack of risk prevention awareness related to some of the specific aspects of nanomaterials. For sure, a good design, clear goals of training are needed to show the added value, and awareness interest of OSHA professionals is key. They are the first one that should be convinced. We also, in this slide, we try to summarize some of the elements related to the structure and format of the training that emerged from a survey. In terms of format, a blended one, face-to-face and online format seems the best one, the one that fits better. In terms of meeting the tools, should be tailored to the audience. We need some, there should be a need for some kind of feedback mechanisms to get inputs from the organizations and participants in terms of what they need, what they want from a training, practical experiences. And when we are using online platform and use of emerging tools like virtual reality tools could be a good option. We ask some indicative information about the costs per person of a training, a lump sum for a single person, 100 to 500 euro, the option more selected, followed by 500 to 1,000 euro, maybe for little groups of people. Duration for face-to-face, at least one day, maybe more, online just few hours, maybe delivered on a longer period. So overall, we need modular, flexible elements to tailor them to the specific needs and maximize the benefits, and of course, affordable. Here it's summary. It's like a training fact sheet. Target audience, training the trainer, that's first of all. Harmonize and knowledge methods and procedures should be the objective. Addressing anticipation, awareness, and prevention of risks. Modular blended format, we said. It could be ideally something distributed along a period, maybe 1 year, where you have some 1 or plus days face-to-face meetings when you work with case studies, hands-on experiences, plus brief online modules during the year, adapted to the needs of the audience. The topic should be selected on a need base. Would be nice to have a simulation of real cases, real situation in the working environment, for example, the handling of nanomaterials. Teachers need to be experts, of course, occupational hygienists, health safety consultants. Ideally, these people, the teachers, should include an expert, an external expert, and the manager, the health and safety manager, the ones that are in charge of overseeing and control the safety of a lab or production site. We need organizations that are authoritative and experienced, and I think all the PEROSH network perfectly fits with this definition. So in conclusion, we need focused initiatives tailored to the organization need to engage in rising trends. So a kind of cooperate and co-design the training with the target organizations. Our impression is that private initiatives are likely premature given the level of knowledge. So public action here is key. It's important, we think, to transfer the knowledge of more than a decade of experience on risk analysis of advanced and complex materials. Developing standard training modules and online material would be perfect, and then test them in case studies and adapt them. And this is really a call open to all PEROSH members. I just want to mention a future initiative from Europe and European member state. It's called I'm4U. It's a public-private partnership on advanced materials under discussion just now. We'll start, I think, in 1-2 years, and it will be a large investment on advanced materials. It could be an opportunity to cooperate and develop future training on risk analysis. So overall, our ambition is to promote professional training on state-of-the-art approaches for risk analysis of advanced materials. So again, this is a call to compile our second round survey so we can compare with the results of what we did almost 1 year ago. And thanks a lot for your attention.
Okay, thank you very much, Andrea. And indeed, that was the QR code, probably the same as Fabio showed, where you can people can join the second survey. Maybe a question to you, Andrea. Do you have the impression that workers are really keen to have more information and training on advanced materials, nanomaterials, when they are working with this?
It much depends. Sometimes it's underestimated what could be. I mean, there's a lot of guidance available. We need to say this. I mean, so people know that in some cases they need to take specific protection measures, maybe using the experience they have on other kind of chemicals. So this is known, I think. But I think the training and working on OSH, it could be really beneficial because it's a way, of course, to prevent risks, but it's also a way to better understand and know your full process and the details of the full process. You know, when you do an exposure measurement campaign, you are going to characterize very well your process, even maybe beyond your normal quality standards. So this could be another aspect, another added value. But of course, it's something relatively new. You know, for example, going beyond the usual mass matrix approach is something that it's really new for, I think, many labs and production sites. Yeah.
And this is a question to you, Andrea, but maybe also the other speakers can reflect a bit on this. Is, let's say, the use of nanomaterials and advanced materials, is this really on the rise in production environments? Or has this been stabilized? Or is this still ongoing? Is this still growing in new products, new materials?
What I think happened in the last 10 years, that's our impression, nanomaterials became really a commodity for some companies and industries, but not for all, of course. And we are just speaking about specific nanomaterials. Just maybe titanium oxide is a good example, but we can find others. And the level of risks or attention you need to consider regarding safety is completely different depending from the type of materials you're using and the type of conditions you have. So you cannot really generalize. There are really low risk situations. There are few maybe high risk situations. People know about some production types in terms, for example, of carbon nanotubes. There's an attention. There are production sites that are taking care of this, but we need to know. And for the advanced materials, they're growing. They will grow even more. That's the issue of complex and multi-component materials that is quite difficult to deal with. So there are open aspects that I think would be for science and technology and for risk analysis as well.
And do we already see, let's say, workers becoming ill, occupational disease, because they were exposed to these nanomaterials, advanced materials? Are there examples of these, or are we still in the, let's say, the precautionary principle phase that, okay, let's try to avoid any sort of exposure to these nanomaterials and advanced materials?
No, let's say, and this was one of the results of the 4 years of research of Go for Nano, there's been no evidence of any critical accident related to nanomaterials in the last 10 years. So we are on the safe side, but we need to say that a lot has been done in terms of precaution in the use of nanomaterials. Really a lot. So the message was clear. And maybe we don't need training. Anyone knows? I don't know. I'm not sure about this. But anyway, it's something we need to confront with, at least for a specific type of nanomaterials and specific conditions to use. Make it simple when you have a powder compared to when you have a solution. That's completely different situation.
Okay, clear. Okay, that makes it clear indeed. And the precautionary principle is paramount here, of course. That so far, apparently no serious results. But let's take it on the safe side to avoid this exposure. Because I know that when you speak to experts or workers, you know, that as soon as the word nano is mentioned, then some people become a bit hysteric, you know, that, oh my God, this is so awful, nano, you know. But you should know and realize what it is indeed, and how you can be exposed, and how you can protect yourself if you don't want to be exposed to those.
Many companies, for example, decide to use colloidals, you know, and suspensions to completely avoid any kind of exposure during the production site, just to make an example.
Yeah, this is good. Is this something that we have learned from asbestos, where in the beginning also some knew that it was dangerous and others neglected it?
I would let maybe the others have more experience on this than me. I would just say that there are so many differences. Yes, that was an historical thing that made us aware that we need to take risks seriously since the beginning. You know, and at least I think in Europe we did it for nanomaterials. You know, the definition is from 2011. The first regulation, cosmetics, taking into account nanomaterials, is from 2009. That was the very early stages of the commercialization of nanomaterials.
Okay. Okay, thank you very much. That clarifies a lot for me. I'm not really an expert in nanomaterials, but this makes sense, absolutely. Thank you. So we will go to our next speaker. His name is Neeraj Shandilya. He works at TNO in the Netherlands, and he will speak on the specific needs and expectation of workers and employers and their main issues and their challenges to address practical advices. And Neeraj is working as an innovation scientist at TNO for the last 7 years. He obtained his doctorate degree in industrial process engineering in 2015. His research focuses on safe development and risk management of chemicals and materials, and his expertise lies in the fields of aerosol dynamics, material science and occupational hygiene, and he has authored many papers in these fields. So, Neeraj, the floor is yours.
Thank you, Jan-Michiel. So today my talk is going to be mainly focusing on the worker and the employer. So what are the specific needs and expectations, and what sort of issues and challenges are there when it comes to the worker safety? So as Jan-Michiel mentioned, I've been working at TNO, and at TNO we have been actively developing different tools and methods to develop and help preventing worker exposure, among many other things, and advise private and public companies in doing so. So nanomaterials. Here about the exposure to nanomaterials. This is going to be the brief overview of my talk. So first, I'll start talking briefly about the health effects on the workers, some of the regulations which are in place. Then how can one identify the nanomaterials at the workplace and assess the exposure very briefly. Then what sort of medical surveillance programs are there, and do we need something new in them? And then finally, some recommendations or information on some sector-specific exposure control measures in 3 sectors particularly, so healthcare, maintenance, and the construction. So starting with the first topic, which is about the health effects here, the nanomaterials, we know about that they interact with biological systems differently from the larger particles of the same material. So for example, nanomaterials may show altered rates of absorption into the body, and once absorbed, they may reach parts of the body that larger particles are unable to. Then also the same mass of nanomaterials will have a very much higher surface area than an equal mass of a macro form or a bigger size with the same chemical composition. So this larger surface area may be reflected in increasing biological reactivity, which ultimately results in a greater toxic dose response. The toxicity shown by a nanomaterial may also be influenced by the presence of surface coatings or the material's tendency to form agglomerations. Now, what is important to understand from the worker exposure point of view is that there can be multiple routes through which a worker can get exposed to nanomaterials while working with them. So this includes inhalation of nanomaterials, due to which the nanomaterials may be readily absorbed through the lungs and transported to other parts of the body, where they could potentially cause a toxic effect. The skin contact with nanomaterials is also possible, which could also lead to adverse consequences. However, available evidence suggests that the nanomaterials are not generally expected to be absorbed across healthy skin, but rather through bruised or damaged one. Oral ingestion, it's generally not a concern in the workplace. However, there are some instances, for example, if there is poor occupational hygiene practice is there, or for example, work clothes are not being changed regularly, or hands are not being washed before eating. So such practices, they might lead to the oral ingestion. Now, currently, there is an uncertainty as to the extent to which the various characteristics of nanomaterials influence toxicity. Through the development of new approach methodologies in some of the recent EU projects, research has suggested that in several cases, the physical properties of a nanomaterial, so for example, the size, shape, or the crystal structure of these nanomaterials, they may be important in determining the nature and extent of the toxicity. Particular concern is regarding the fiber-shaped nanomaterials or other advanced nanomaterials. The next topic is about the regulations. So Fabio and Andrea already hinted to it, so I won't go much into the details on that, except to mention that there are some of the existing directives which apply to nanomaterials, but they do not explicitly refer to them. So this includes like chemical agent directive, CLP regulation, the carcinogen and mutagen directive, as well as certain substance-specific legislation for chemicals. For example, we have REACH. So for cosmetic products, there are certain specific regulations. For medical devices, biocides, food contact materials, we have separate legislations. However, to repeat, the directives, they are not really specific to nanomaterials. Now, it is the responsibility of the employers right now to assess and manage the risks of nanomaterials at work, and thus adhere to these regulations at the workplace. Although many uncertainties remain, there are high levels of concern about the safety and health hazards of nanomaterials. Therefore, the employers, together with workers, must apply a precautionary approach. So as Jan Michael mentioned, this precautionary approach is important right now to risk management and the choice of prevention measures. So if the use and generation of nanomaterials cannot be eliminated or substituted by less hazardous materials and processes, EU OSHA, it mandates the implementation of prevention measures at the workplace in the order of the priority and effectiveness, as shown on the right-hand side at the bottom. So first, if the elimination and substitution doesn't work, we start with the engineering controls at first. So the implementation of the measures like local exhaust ventilation, worker enclosure, source segregation, etc. Then we have administrative controls, which include like standard procedures, training, warnings, etc. And finally, if none of them are working, then we have the last resort, which is the personal protective equipment, which is the least effective measure. And it includes the safety glasses, respirators, protective clothing. Then the standards and documentations, they are important aiding tools for the regulations. At the EU level, the health and safety standards development is led by the European Committee for Standardization, also called as CEN, and more precisely by the Technical Committee CNTC 137 and 195, as well as the OECD's Working Party for Manufactured Nanomaterials. Nevertheless, there is a considerable potential for regulatory gaps which need to be filled. This include, for instance, the mass-based exposure thresholds set within the regulations, which are generally inappropriate to nanomaterials. The regulations are generally narrow in scope and in interpretation for their applicability to nanomaterials. At several instances, due to the lack of standardization often judgment needs to be exercised by employers for OSH professionals. There's also a need for the standardization to support the preparation of MSDS, the material safety data sheet for nanomaterials labeling, namely the specific content and guidance about what should be considered in the different mandatory sections of the MSDS. Coming up to the next section of the presentation. So this is about the identification. How can one identify nanomaterials at the workplace? Also the exposure. So in order to establish if there are nanomaterials present in the workplace, one should look for information on the product labels. So this is the first step where one can look for. And in the information is normally present in the safety data sheet, the product labels, and also in the technical specifications. These may identify whether one or more nanomaterials are present, but in some other cases, such checks may not clearly establish the material status. If that is the case, then the worker should ask the safety manager or an occupational safety and health professional, OSH professional. In such circumstances, they should be able to either advise the worker directly or seek information from the supplier, whether or not nanomaterials are present. Still, if there is no such confirmation possible from the supplier, then the responsibility lies with the employer to identify the presence of nanomaterials, which can be done based on either workplace analysis through on-site exposure measurements or through the use of different web-based interactive tools like Stuff Manager Nano, Control Banding Nano Tool, Non-Exposure Quantifier, etc. In the following talk, Araceli will briefly also talk about the workplace analysis through exposure measurements. Then based on the data gathered so far, there are some typical situations which are known to have the potential for worker exposure. These include frequently impacting contaminated surfaces or objects, working with dusty powders or liquids, which have low viscosity or high vapor pressure, then activities like cutting, abrading, grinding, nano-enabled objects, improper use of the personal protective equipments like wearing mask on a big beard, etc. So if any of such situations, and an employer must take arrangements and ensure worker safety at the workplace. Then we come to the medical surveillance and what sort of needs do we have regarding the current status of the medical surveillance. So medical surveillance, it targets actual health events or a change in a biologic function of an exposed worker. It is considered as rather a second line of defense behind the implementation of engineering, administrative, and work practice controls. The elements of a medical surveillance program generally include initial medical examination with medical and occupational history of the worker, then periodic examinations at regular scheduled intervals, and finally, post-incident examinations. And it is the responsibility of the employer basically to train the worker to recognize the symptoms of exposure to a given hazard. This allows identifying the workers who have or who are developing adverse health effects due to their exposure to nanomaterials. A medical surveillance program can also be used to avoid worsening of symptoms by implementing preventive measures. Now, such a surveillance program is not only for the risk prevention purposes, but it can also improve the predictive value and provide medical as well as socioeconomic benefits to the employer. Due to, for instance, we might have fewer cases of disability over the years due to an efficient medical surveillance program. We can have lower direct costs and productivity losses and incremental cost effectiveness ratio due to cost saving on the reactive measures to take by the employer upon incidental worker exposure to hazardous nanomaterial. So such medical surveillance program also carry some of the economic values or benefits for the employer. Now, unfortunately, there are no medical surveillance standards at European level that are specific or specifically address occupational exposure to engineered nanomaterials. This is mainly due to insufficient evidence to recommend the use of specific medical screening or surveillance of workers potentially exposed to nanomaterials. Thus, the default approach has been to take a preventive and precautionary approach, which implies taking hierarchic exposure control measures, as well as I showed before, to minimize worker exposure. Now, with the purpose for the early detection of the adverse health effects and prevention of long-term worker health risk, several directives, although not specific to nanomaterials, can be relevant. This includes Occupational Safety and Health Framework Directive, Carcinogens Directive, Biological Agents Directive, and Chemical Agents Council Directive. For such directives to be more effective, there are several recommendations which include like biomonitoring of adverse health effects using validated candidate biomarkers of exposure, then development of exposure registries where longitudinal follow-up studies should inform surveillance, non-exposure measurements or summary indices for nanomaterials as a reference, or we can also have the studies that compare the effects of these surveillance approaches to usual care. So for example, those commonly followed for bulk-sized or conventional hazardous material. Coming finally to the last part of this talk, which is about some information on the sector-specific exposure control measures. So first, we'll see some information on the healthcare sector. And due to the nature of the work in the healthcare sector, most workplaces, such as patients' room in hospitals or even patients' homes, may not have, let's say, technical systems for reducing or preventing exposure to nanomaterials at source. So for example, closed systems that create a physical barrier between worker and the nanomaterial, that's not always the case. It is present. However, engineering controls at source are feasible in other operations, such as preparation of tablets or ointments containing nanomaterials in glove boxes. One can have clean benches with HEPA filters. They are also very efficient risk prevention measures in the healthcare sectors for activities such as the preparation of nanodrugs, sampling patients' tissues, body fluids, or excrements that could contain nanomaterials. One might have exposure to spills, dust, or vapors to nanomaterials from different samples in the healthcare sector. And such exposure should be controlled by the use of high throughput ventilation system in combination with, let's say, PPEs, particularly gloves and masks. Local exhaust ventilation systems, they're also normally in place in laboratory workplaces or surgery rooms, storage rooms, or areas with high safety standards. This is mainly because of the reason that there is a high infection risk in such rooms, and normally to prevent that, there are local exhaust ventilation installed there. And such local exhaust ventilations, they are already capable of capturing nanomaterials. However, in the case of nanomaterials, the use of normal multi-stage filters with high efficiency H14 HEPA filter or ultra low penetration air filters as the final filter before reintroduction of the extracted air is recommended. In any case, the suitability of the filtration systems in place should be evaluated regularly. The next sector is the maintenance sector. Here, the golden rule is to control the exposure in the maintenance sector, is to implement the control measure at the emission source. And the most efficient engineering control at source is containment through the use of closed systems and enclosed installations. Where containment is infeasible, suitable effective local exhaust ventilation systems with HEPA or ultra-low penetration air filters, they're also efficient to capture nanomaterials at source. In some cases, the maintenance work itself may actually consist of inspecting and repairing these technical controls, and the preventing function of these engineering controls may therefore be disabled. This may happen when, for example, in situations like nanomaterial production vessel is open for maintenance work and the exhaust system is therefore stopped. So in such situation, the maintenance worker must then rely on personal protective equipment. The mobile air extraction systems may be particularly helpful to protect workers from exposure in such situations, and also during other tasks like removing paints from surfaces, which results in particle formation. When using these mobile air extraction devices, one should pay attention that the workers' breathing zones should not be within the airflow between the potential nanomaterial emission source and the exhaust extraction system. And lastly, the ventilation systems used to control exposure to nanomaterials, they must have a multi-stage filter with HEPA or ULPA filters as the final filter. The construction sector, the last sector to talk about, here we have cement and concrete materials and coatings and paints. These are the products which share some of the largest market within the construction sector. And there are several activities when working with cement and concrete materials which do not involve any dust generation. So there can be some activities like pouring concrete, stripping the formwork from concrete components, cleaning formwork, etc. So for such activities, no special exposure control is needed. However, performing activities like spraying concrete or drilling in concrete or blowing out boreholes, etc., they can generate a lot of aerosol or dust. Thus, these activities should not be performed without protective measures. So for instance, spraying concrete should be done while wearing a full protective suit with helmet with forced ventilation. Similarly, systems like extraction drill or vacuum cleaner adapter should be installed during drilling in concrete or dust removal during blowing out boreholes. The drivers of the construction machines and vehicles should keep their vehicles' doors and windows closed. The construction site roads should be kept moist with water and dust binder. And when demolishing any concrete structure, tools like jackhammer with extraction and air cleaner should be used. When using an excavator, the worker inside its cabin should keep the doors and windows closed. And while the worker near or between the excavators should wear helmet with forced ventilation. And the final slide, continuing with the construction sector, is mainly about the paints and coatings. So while working with paints and coatings in the construction sector, especially during their spraying, ventilation is very important. An exhaust ventilation system with a HEPA filter can drive away airborne nanomaterials from the immediate workspace. The exposure risks are lower when a brush or a roller, than using a spray pistol. Individual respirators with FFP3 filters should be worn by the worker while paint spraying. Other essential PPEs include eye protection with chemical goggles, coverall, and gloves to prevent skin exposure and minimize worker contact. Then stable and robust boots to reduce worker exposure and prevent slips. And there can also be proper housekeeping strategies to reduce the worker exposure levels. This can include using disposable containers for mixing substances so that the leftover paint can be removed from the environment quickly. Contaminated tools must be covered or moved to a well-ventilated location when not in use. And following each shift, the workers should manage and clean their workspaces to reduce the exposure risk to the accidental spills. So that's all I had to say. Thank you.
Thank you, Neeraj, for this very practical presentation, which clarifies a lot. In what sort of sectors can we see possible exposure, potential exposure of nanomaterials, and what sort of measures can you take to avoid these? Really nice, very nice to see it. We have a few questions, and I would like to ask you, Neeraj, maybe 2 out of these 4 questions. One remark was, of course, will the presentations be shared? The answer is yes, these will be shared. Of course, if the presenters allow this, and we will upload all presentations in the repository of PEROSH. Again, have a look at our website, and you can have a look for free at our repository, where you find loads of materials, presentations, free to use and downloadable. And of course, this is what I told at the beginning of the webinar, we will have a YouTube video posted on this webinar, and there you can also again see all the presentations. That was one question. Now there was a question because Neeraj, it was really nice you showed a few of those sectors. One question raised the issue of 3D printing, which is of course becoming more and more popular even at home, where customers just at home have a fancy to print in 3D all sorts of objects. There is exposure there of dust, maybe of nanoparticles. Do you believe this should also be included in a potential exposure scenarios of workers or consumers?
Definitely. This additive manufacturing, like the 3D printing, this is, I think, one of the focus areas when it comes to the nanomaterials exposure. And I don't have the names of the project on the top of my head, but I think there are at least a couple of the EU projects which are looking closely at it. What sort of consequences do we have in consumer scenarios or industrial scenarios when we are working with this additive manufacturing technology? Since this technology is fairly new compared to the sectors that I talked about, there is not much information available, or the research, as I said, is still ongoing. So it was a bit early, and I would say the knowledge is underdeveloped for the moment. At least that's what I think. People might think differently. But the knowledge is still being developed to be shared and discussed. But of course, it is one of the important sectors to look at.
Okay, thank you very much. Then there was another remark, and this is also what we discussed with Andrea before, and you, Neeraj, also showed it in one of your first slides, that currently there seems to be no clear evidence of toxicity, of health effects of nanomaterials, and we are guiding into the future based on this precautionary principle, which is really good, of course. This is what we have learned, I would say, from other risks that were first underestimated. One of the questions is that, there seems to be not so much recognition of the potential health effects, negative health effects of nanomaterials. What would be the reason for that?
About the reasons, I mean, one of the main reasons that I see is the innovation, the level of the innovation which has been happening in the nanomaterials. The safety assessment is far outpaced as compared to the innovation which is happening. So, and moreover, the industry, although it is getting there, but the interest of the industry, and it have been mainly on the functionality part, which should have been there, of course. So the profits and things like that. And the risk assessment strategy that we have been following until now, we have been talking about mainly the science and the safety part, etc. We haven't been thinking about how beneficial can it be beneficial for the industry. That's why we have these concepts like safe and sustainable by design, where we not only see the safety part, but also the functionality part. And we're also trying to develop some business model around it. So for example, if an industry tries to adopt this, whatever the size of the industry be, how such a practice of the safety risk assessment be beneficial for the industry. And once we have this business model around, or the safety assessment becomes beneficial for the industry or the innovators out there, I believe, personally, I think that the pace through which we have been moving ahead, it will be much higher.
Okay, thank you. That makes it clear. And I was also thinking, how long are we talking now about nanoparticles? Maybe 5 years, maybe 10 years. If you compare this to, let's say, the exposure to asbestos, it takes a long time before indeed a negative effect is seen in human beings. That also might be an explanation. So Still, at the moment, we stick to the precautionary principle, if I'm correct. Please correct me if I'm wrong, but that is my impression of your presentations, and also
this is the in the lack of evidence. That's the best way, because there are so many situations where you don't have much information. So this is the best way to go ahead.
Correct.
The precautionary way. Yeah.
Yeah, correct.
Yeah, Jan, if I can
please,
make
Andrea.
one second. Yeah, and moreover, there are so many type of nanomaterials and nanoparticles, and their hazard profile is completely different, from very low hazard to high hazard. So we need to combine those aspects. There are nanomaterials that are not at all risky, with very low hazard profiles. Just take nanostructures, for example, and others that need scrutiny. So the parallel with asbestos is, for me, is not so appropriate, as it may be true just for specific classes of nanomaterials. For the others, it's not. And I think that's the discussion on contrabanding tools, and of course the usual paradigm of combining hazard and exposure. It's the basis for any kind of, reflection on the final risk profile.
I think that we need to compare the asbestos only to highlight the possibility to anticipate.
Yeah, correct.
A new risk.
It's more the process
not about the effects.
Yeah, correct.
But I think that the presentation by Araceli will be more clear also in this point. So I will leave the floor to Araceli. Thank you.
Okay, thank you, Fabio. Indeed, I was referring more to the whole process of awareness raising, what we saw with asbestos exposure. Are there some similarities that we have now with nanoparticles? Okay, there was one more question, but I will save this question for the Q&As at the last part of this webinar. And we will continue with our last speaker, a female speaker. Welcome in this man group. I would say her name is Araceli Sanchez. She works at the Spanish Institute, the INSST, which is also a member of PEROSH. And she will share with us the specific needs and expectations of OSH professionals, and the main issues and challenges to address practical advice. So you see that we come a bit closer to really the practical advices on the shop floor. Araceli received a PhD on air pollution and health from Strathclyde University, and a Master of Science on Occupational Hygiene by Manchester University. And her expertise is on the assessment of exposure and risk of chemicals, especially in occupational settings. And over the last 15 years, she has been actively involved on the development of methodologies and for the risk assessment of manufactured nanomaterials. And Araceli is, as the two Italian colleagues, also part of the Spanish delegation at the OECD Working Party on Manufactured Nanomaterials. And currently she is involved in the project Safer and Sustainable Innovation Approach for More Sustainable Nanomaterials and Nano-Enabled Products. Araceli, please, let us have your presentation.
Thank you, Jan. So in this last part, having problems, okay, now it works. So in this last part of the webinar, I'm going to talk about the main challenges faced when performing the risk assessment, why we need new training, and also I will show some of the content of the training we are preparing. So as you know, the main role of this professional group is to conduct the risk assessment, to implement risk management measures to protect workers' health. And this has to be done in accordance with current legislation. In Europe, we have the Framework Directive and also its DOTA directives. Apart from REACH, there are no specific regulation for nanomaterials, as Neeraj just mentioned. Nanomaterials are covered by the Chemical Agents Directive, and in the case of being classified as carcinogens or mutagens, by the Carcinogens Directive. worth to mention that in the last update of the PPE regulation, nanomaterials are mentioned as an example of a substance that may need the use of PPE. And then REACH includes specifications on the safe use of a substance. If a substance is not used according to those specifications, this has to be communicated to the manufacturer so that use is evaluated and included in the list of safe uses. Other pieces of legislation include the directive related to safety. Nanomaterials, especially metals in powder form, they have a high explosivity index, so the directive on ATEX has to be taken into consideration. And also other relevant directives are those that address vulnerable workers, especially when we work with carcinogen substances. This is just a recap of the results that Andrea showed. 98% of the respondents indicated that they wanted training on how to perform the risk assessment. And 77 indicated that they would prefer this training on the form of case studies. Well, these results were not a surprise when you look at the resources that they have to perform the risk assessment. The first step is to identify whether the substance is hazardous, and the safety data sheet should include this information. But most safety data sheets have missing or incomplete information. In this study, they evaluated safety data sheets for graphene, and 46% were deemed non-informative, and 73 were classified as required major improvements. And this is just an example, but there are many other studies that have arrived at the same conclusions. Then the REACH dossiers also have a lot of useful information on the hazard and also on the exposure and on the different life cycles. However, in 2020, there were only 36 nanomaterials registered. I don't have the numbers with me, but I believe there are more than 36 nanomaterials in the market. And then the chemical safety reports also include a lot of information on the hazard and also on the exposure scenarios, but they are mandatory only if the substances are manufactured in quantities over 10 tons a year. And this is not the case with nanomaterials. Then when it comes to evaluating the exposure, there are a range of control banding tools, and Neeraj mentioned some of them, and also there are quantitative models. However, the information, the input data that you need to use these tools is not available. And also these tools are not recognized by ECHA to do a regulatory risk assessment, as for example, are recognized other tools like ART, Stock Manager, or STOCTRA for conventional chemicals, despite the efforts of the scientific community. The OECD in 2020 published a report on the evaluation of these tools for occupational exposure and also for consumer exposure. And also some of the colleagues here today, Neeraj, Andrea, Kale, and Wouter, they developed a framework to improve the regulatory acceptance of these tools, and they demonstrated these tools against the framework. But still, there are no, as I said, tools that are recognized by ECHA for regulatory risk assessment. And then if the occupational and health professionals want to carry out measurements to check, for example, whether the exposure controls, for example, the local exhaust ventilation, is adequate to prevent exposure, there is a standard, but this standard is over complex, it requires the use of expensive equipment, a high level of expertise, and it has an elevated cost. And then most recent challenges include the last updates on the carcinogen directive that include cadmium and nickel. And these two metals are commonly used in nanomaterials. Also, the introduction of new materials like advanced materials. And recently, the European Commission published a framework for the safe and sustainable by design of chemicals and materials. And this framework in the step 2 requires the information on occupational exposure. The framework is for to use for industry on a voluntary basis at the moment. And the advantage is like, hopefully in the future, it will facilitate the role of occupational health and safety professionals because there will be fewer toxic substances in the workplace. So having this in mind, the training is going to include resources for hazard identification, a simplified exposure monitoring strategy, guidelines on how to assess exposure to advanced materials, and examples through case studies. And I'm going to show you now a bit of these resources that we're going to include on the training. So in regard to the resources for hazard identification, EU OSHA is it's a good source to identify exposure scenarios and also for risk management measures. But for more specific information on the hazard, the search function in ECA has links to the REACH dossiers if the substance is registered, as I said, and the REACH dossiers have a lot of information on the toxicity, environmental toxicity too, and the physicochemical characteristics. All this data that is needed for these control banding tools. Also, the European Observatory for Nanomaterials is regularly updated with the latest developments, and it has links to databases, like, for example, NanoData and the NanoMapper, where a lot of information that has been collected in European research projects have been uploaded to these databases. And they include information on the physicochemical properties of the material, the toxicity, and also on the exposure scenarios. And then it's worth checking to the webpage of the Working Party of Manufactured Nanomaterials, because they published lots of reports, and some of them are also relevant for the risk assessment. So apart of the training material, we will include also a summary with the current reference occupational exposure limits, apart for these ones that have been for a number of years from NIOSH in the US, Britain, and Germany. Denmark published recently a suggestion for an occupational exposure limited for titanium dioxide and also for carbon nanotubes, according to the mechanism of action. A threshold value to reduce the risk of cancer, and also a threshold value for other effects where you can, other effects that have a threshold. This is the derived non-effect level. And then in relation to the exposure assessment, we are going to suggest a simplified approach for the monitoring strategy. But I want to justify why are we doing this when there is already an standard on exposure. So let's go and have a look to the standard. The standard suggests a clear approach. In tier 1, information on the exposure factors is collected, and if there is an indication of exposure, then risk management measures have to be applied before moving to tier 2 or tier 3. In these tiers, the standard indicates the use of direct reading instruments to collect information on the particle number in the air. These instruments work for a specific size range. In tier 2, the standard suggests to use portable instruments like those that you see here. And in tier 3, the standard suggests the use of more sophisticated equipment to analyze the entire particle size distribution. And as part of the 2 tiers, you also have to collect filter samples for microscopy analysis through SEM or TEM. And then the standard also includes like a metrics to combine the results from these direct reading instruments and the microscopy analysis to arrive at a conclusion on the likelihood of exposure. As I mentioned before, the use of this equipment is complicated. The equipment is expensive, and we think that a simplified approach could be used. But before I show you this approach, I'm going to share with you some of the challenges associated to the use of this direct reading equipment that the standard relies heavily on. nanomaterials have a tendency to agglomerate, and therefore there is a need to assess the size range that has to be measured, which means what instruments to use, because, for example, this instrument worked for a specific size range. This one is a CPC and only measures the number of particles that have a size below 1 micron. So if your nanomaterial forms agglomerates of 4 microns, you're not going to see it using this piece of equipment. Then there is also a need to address the background. This instrument discriminate by size, not by the chemical nature of the substance. So they measure all particles that are in the air in the size range that the instrument measures. I mean, it's going to measure your engineer nanomaterial, but any other nanomaterial coming from a different source. So it's very important to address the background. And then there are limitations just associated to the equipment itself. This equipment is designed to measure spherical particles, so there is an error if you use it to measure, for example, graphene or carbon nanotubes. And then they have a high uncertainty, like around 20 or 30%. But let's gonna see an example so you can understand better what I mean. This is a time-series plot of the particle number during a process where polyamide was extruded with carbon nanotubes. In blue, we have the extrusion of the polyamide only, without the use of the carbon nanotubes. In yellow is the extrusion of the polyamide with the carbon nanotubes in master batch, and in red, the extrusion of the polyamide with the carbon nanotubes in powder form. So, in theory, I would expect to have higher concentrations when I'm using the powder. But if you look at the peaks, it's very difficult to extract from these results whether there was exposure to carbon nanotubes or not, because there were so many other sources of particles that I cannot tell what to refer to. You have to compile a lot of contextual information and being basically next to your instrument, taking notes on what is going on. In this case, it was the analysis by SEM and EDX what revealed the presence of agglomerates of carbon nanotubes. So this is the reason why we are suggesting a simplified approach, that it could be based on the standard. I mean, the standard is very comprehensive, and it should be considered as a gold standard if you have the equipment and the resources to run it as it stays. But for routine analysis, we're going to suggest like a few extra guidelines. We're gonna explain how to use control banding tools in tier 1, and this approach has been already suggested by our colleague Fabio in a paper. And then for tier 2 and tier 3, we're gonna also offer guidelines on the use of quantitative models and a simplified sampling strategy that I'm gonna show you now. For the simplified monitoring strategy, we're gonna start asking whether there is already a mass-based referent occupational exposure limit. And if that's the case, then to suggest a chemical analysis. If that's not the case, but the nanomaterial is a high aspect ratio nanomaterial, then the preferred method would be either SEM or 10 to count the fibers. If this is not the case, the next question is to address the background. If there are other sources of nanomaterials, like because of other processes, diesel engines, or outdoor sources, this is going to result on a high and variable background. So if I do not expect to have these sources and my background is going to be steady, then I can use direct reading instruments, because most of the peaks are going to come from the engineered nanomaterial I'm handling. But if the case is that I have a high and variable background, then it's going to be more informative to use microscopy analysis or chemical analysis. So the next question is to evaluate whether the same, I mean, if there is in the workplace a material with the same composition that the engineered nanomaterial that I'm investigating. Because if the answer is yes, it's better to use a microscopy analysis, since in the chemical analysis, you lose the information on the size. So for example, if I want to analyze carbon nanotubes and I have in my workplace 3 diesel engines and I analyze the elemental carbon, I'm not going to know what part of the elemental carbon comes from the diesel and what comes from the carbon nanotubes. All of this taken into account that both could be carcinogens and maybe it's actually worth to measure the full concentration of elemental carbon. But in here, we are just focusing on the exposure to the engineered nanomaterial. And then we are going to introduce guidelines or guidance on how to assess the background. The standard has like a few rules to evaluate whether there is a statistically significant difference in the particle numbers when you're handling the nanomaterial and the particle numbers of the background. But it doesn't say how to assess this background. So there are basically 3 methods. You can measure simultaneously during your activity. For example, here in red, it could be measurements taken in the so-called far field meaning 1 meter away from the source. And then you measure near to the source in yellow. Obviously, this method requires to have 2 equipment, one for the source and one for the far field. But you can also measure before you start handling the nanomaterial and after. And you can use the before and after as your background. Or, especially when you have process-generated nanoparticles, you can measure during the process, but without using the nanomaterial, as I showed in the extrusion process before. And then you can take measurements when you use the nanomaterial. And then applying this rule, you can see whether there is a statistically significant difference between both. So we're gonna use this flow diagram to aid occupational and health professionals to select the type of background. So the first question here is to evaluate to see whether you have a background concentration that could be very variable. And when it's going to be very variable? When you have other processes, when there are open doors and windows, when there are a lot of movement of workers. If you do not have these processes, like for example, in a research lab, where most of the peaks are going to come from the use of the nanomaterial, then you can measure before and after and use that as your background. If your background concentration is going to be very variable, then you have to see whether those particles are coming from your process. If the answer is yes, then you can measure without using the engineered nanomaterial, as I just showed before. And if the answer is not, if your background particles come from other sources, from outdoor, then you can use simultaneously during the process in the far field. Sorry, that was just like to illustrate when an example of when particles can come from the same process. Like the most typical example is like an extrusion process. And then I wanted also to mention the definition for advanced materials. Fabio mentioned it also in his slide. ISO is working on a harmonized standard definition, and the European Commission and the OECD have also published definitions that they mostly refer to the same concept. These are materials that have enhanced properties for an improved functionality. As you see, the description is not in terms of the size. So advanced materials can include nanomaterials, like for example, graphene, if they are under 100 nanometers, but there could be other type of materials. And there could be formed by a single component like silica or carbon nanotubes, but also they can be made out of different blocks. They can be hybrid materials. And therefore, the assessment has to be done to the whole entity of the advanced material, but also for the specific components, because as I said in the earlier slide, some of those building blocks could even have carcinogenic metals, like for example, cadmium or nickel. So as a summary of what aspects are going to include for occupational health and safety professionals, will include information on how to collect data for the hazard identification, how to use qualitative and quantitative methods, and also will include examples either in research laboratories, but also for industrial applications. And if you haven't done so yet, please answer the questionnaire and let us know your opinion.
Araceli, thank you very much for this very detailed description of guidelines, already existing guidelines, norms, standards that are currently available. We are almost at the end of our webinar, and all of a sudden, this is what we see, quite a few questions dropped in. And I just want to mention a few. Maybe we cannot deal with all of them. But for instance, there was a question on, and I think, Araceli, you mentioned the word, I'm not quite sure, nano-enabled objects. Or it was someone else, maybe Neeraj, I don't know. But the question is, what exactly are nano-enabled objects? Do you know a few examples? Maybe some of them?
Yeah, well, I think this word came with the standard. Because
it's in the standard, the word.
The 17058 for exposure, the standard that I show in my presentation, they use the nano object or agglomerates because nanomaterials can have different shapes. So I think they try to use this terminology to englobe all nanomaterials with different shapes.
To cover all these materials.
To cover all the different shapes, yes.
Okay. Thank you very much. And then, Araceli, there was a question, are there any benchmarks to assess the exposure to nanomaterials? I think you gave quite a few examples.
Yeah, there are many. I mean, as I said, NIOSH in the US has developed, Britain, Germany, Denmark recently, there are.
Yeah.
I would say not all of them are health-based values.
Okay. But there are a few. And this question just came in before your presentation.
I would highlight.
Sorry?
In the lack of official, in Europe we don't have official occupational exposure limit.
No.
But in the lack of that, I think it's a good idea to use them.
Yeah, exactly. Okay, so that is covered. And then we have two final questions. One is, how can one know whether nanomaterials under evaluation agglomerate, so they clot together, so to say, so that the right measurement strategy can be followed? I think that's a good question, you know?
Yes, I would say, well, I don't know, I'm taking over here. Maybe some of my colleagues want to answer too. I would say, I mean, it's very easy to see it on an image under a microscope, obviously. But you have to have measured for that previously.
Yeah, and
so if you don't have that information, maybe just looking at the literature. But most of them, they have a high, unless they are very rigid, like, for example, silver nanowires. Like they have a high tendency to agglomerate, like titanium dioxide, for example, carbon nanotubes that are bendy. As I said, I think apart from those that are very, very rigid, they have a tendency to agglomerate. That's why it's so difficult their assessment. Some carbon nanotubes are rigid and they behave as asbestos, but some others, they bend and they form like a ball and they're not so toxic.
Yeah. Okay, thank you.
And I think that some characterization analysis will be very useful to identify the behavior of nanoparticles, in particular in real exposure scenario when, for example, they agglomerate or aggregate in the air. So they may have different behavior based on their size and shape.
Okay. Then there was one tip, I think for you, Araceli, again. There is a reliable device, someone says, already some years on the market that can accurately measure carbon-based nanomaterials and differentiate from each other, referring to the calibrated nano you like to check if there is an exposure in your aerosol or not. I use StatPeel. I don't know if it rings a bell. I use StatPeel, their devices, and this is a Swiss product. Yeah, so it's in the chat. Maybe you can check later on.
Okay, thank you.
And then the last question about measuring exposures. Araceli, I think this is also a question to you. Is there any guidance on when to do environmental monitoring and when personal exposure monitoring will be more suitable? Is there any guidance on that?
Well, what the standard says, as I said, based on a clear approach, is like if you have an indication of exposure, you do a basic assessment just to see whether there is a release to the workplace, which I think is what they call environmental monitoring. We used to call it like area monitoring. You don't measure on the worker. Correct. And then if you see that there is an indication of release of the nanomaterial in the workplace, then you take personal measurements to assess exposure.
Yeah, then you dig a bit deeper. What does this mean for personal exposure?
Yes.
Yeah, makes sense. Yeah. Okay, thank you very much. We are a bit over time, but I think we had some very interesting presentations. I learned a lot when it comes to nano, and I think quite a few people of our viewers were really experts, but they also have learned a lot. Thank you, speakers. I will give you a virtual bottle of wine for your contribution. And as said, the video of this webinar will be available soon in our YouTube feed. So have a look at our website, subscribe for newsletter, events, and go to the YouTube feed of PEROSH and also subscribe there, because you will find there many other videos of really interesting research. Thank you so much, and to all people across the world, have a nice weekend, and thank you very much, speakers, and also enjoy your coming weekend. See you.
Thank you.
Thanks, Dad.
Bye-bye.
Bye-bye.
Ja? Oh, zijn ze weg? Ja, dat kan natuurlijk, ja. Dat zijn allemaal...